So moving on, we're going to see chapter 3.4. Here we're going to make use of a matrix operations. We're going to be able to add, multiply, and get the inverse of each matrix. So here we're going to start with some basic math with matrices. When adding a value to a matrix, each individual element goes through the operation. So by element, I mean the values within the matrix. Over large matrices, it becomes computationally expensive. It can certainly be ineffective. So instead of extracting each value and performing a function, we can use something called vectorization. So the same goes for other mathematical values. On the example to the right, we can see that we have an int matrix example, the one we've been seeing all along this chapter so far. It has the values 1 through 4. And we're going to go ahead and just add 4 to the whole matrix. Now you can iterate through where you say, starting at the first position, we're going to start by 1, add 4, then 2 plus 4, 3, and so on. What you can do is you can pass the matrix and apply a function directly to it, which we see here. So a better way of handling operations is to utilize vectorization, as I stated before. The purpose of this is that it is less computationally expensive, applies an operation to a whole matrix, applies an operation to a matrix as a whole and not to each individual element of the matrix. Some standard operations with matrices. We can see here that we can go ahead and multiply or find the difference. So the same notation that you would use for an individual number, you can go ahead and use with matrices. And what's going to happen here is that you can go ahead and add matrices, multiply them, divide them, and so on. You'll just be passing the individual elements to the other elements of the other matrix, which is where you're going to get these values. So getting an inverse of the matrix. In previous math classes, you should have seen what this operation does. It inverts the matrix itself, which intuitively you would think it's matrix to the negative first power or to the negative x to acquire the inverse value of the elements. Much easier way to do this, instead of getting that notation down, is by utilizing a function named solve. Solve is used to get the inverse of a matrix. So here we see the very first matrix that we've been seeing all chapter long, where we can get the inverse by using solve on an int matrix example. Here we see the values of -2, 1, 1.5, and -0.5. So this successfully did create the inverse of it, but we didn't have to go ahead and use the notation that we've probably done in previous math classes.